Hello friends, let us solve one problem of finding resultant of coplanar non-concurrent force system. This is our problem. The sketch is given along with forces. This is coplanar non-concurrent force system. First of all, we have to resolve this 12 kilonewton force in two mutually perpendicular directions, as it is neither acting in x direction nor acting in y direction. Therefore, let us resolve this force along x and y directions. I will use some different color chalk for better visibility. This is x component of this force, f cos 50, that is 12 cos 50, 12 cos 50. Then y component, it is f sin 50, that is 12 sin 50. Both the components will act towards the point, as this is push type of force. Okay, after this, let's find sigma fx value, that is sum of horizontal components of all the forces. This is first force, 4 kilonewton, acting towards right, 4 cos of 0, as it is acting along x axis, angle is 0 with x axis. Need not to write cos 0 because cos 0 is 1, just write 4 and it is positive as it is acting towards right. Then this component, as it is acting towards left, we have to take minus sign, 12 cos of 50, 12 cos of 50. Now let's find this using calculator. 4 minus 12 into cos of 50 is equal to, it is coming minus 3.71 kilonewtons. Then let's find sigma fy value, that is sum of vertical components of all the forces. We have only two forces acting in y direction. This is 12 sin 50 force, it is y component of this 12 kilonewton force, 12 sin 50. As it is acting in the downward direction, we have to take minus sign. Then this 6 kilonewton force, as it is acting upwards, we have to take positive sign. Let's find this value, minus 12 into sin 50 plus 6 is equal to, it is coming minus 3.19, minus 3.19 kilonewton. Now after this, let us find magnitude of resultant by using formulas, under root of sigma fx square plus sigma fy square. The value of sigma fx is minus 3.71 kilonewton. The value of sigma fy is minus it is coming 4.89 kilonewtons, 4.89 kilonewtons. This is the magnitude of resultant. After this, let us find the direction of resultant, that is theta. Theta is equal to tan inverse sigma fy by sigma fx, tan inverse of sigma fy value is minus 3.19, sigma fx value is minus 3.71. Let's find this value, 3.19 upon 3.71 is equal to inverse of tan. It is coming 40.69 degrees, 40.69 degrees. As sigma fx and sigma fy both are negative, the resultant should lie in third quadrant. Now question is whether to place resultant here or here. We are going to find the location of resultant with reference to A. We can take any point. I am taking point A to give the location of resultant with respect to A. Now this no doubt it is in third quadrant, but it should to the left of A or right of A. It depends on the Varignon's theorem of moments, whether it will give clockwise moment or anti-clockwise moment. From that we will decide whether to place resultant here or here. For that, let's apply Varignon's theorem of moments. It gives the location of resultant. We have to take algebraic sum of moments of all the forces and a moment of resultant. What is Varignon's theorem? The algebraic sum of moments of all the forces about any point is equal to moment of their resultant. Now let us take algebraic sum of moments of all the forces. We need not to take moment of this 4 kilonewton force, as it is passing through point A, about which moment is to be taken because the perpendicular distance between line of action of force and the point is 0. Therefore, force into distance which is 0, it gives 0 moment for this force. It gives 0 moment for this x component also, because 12 cos 50 this component is passing through this point about which we are going to take moment. The line of action of force, the distance between line of action of force and the point is 0. Therefore, this magnitude into distance 0, it gives 0 moment. Just we have to take moment of these two vertical forces, 12 sin 50 into line of action of force is this, and perpendicular distance between point and line of action of force is 2 meters 2. Now this is producing clockwise moment, because if you keep this point fixed, a point fixed, and apply downward force, it will try to rotate object in clockwise direction. Now we shall follow some sign convention for moments. We will take clockwise moment as positive and anti-clockwise moment as negative. Then comes this force. Line of action of force is this, perpendicular distance between point and line of action of force is, total distance is 6 meters, and magnitude of force is 6 kilonewton. Therefore 6 into distance 6. This is producing anti-clockwise moment, as this force is acting upward. If you keep point A fixed and if you apply upward force, it will try to rotate this object in anti-clockwise direction. Therefore it is producing anti-clockwise moment. That's why we have to take negative sign, is equal to moment of their resultant. Resultant is r, and distance, let us assume this distance, that is distance between perpendicular distance between line of action of force and the point. Say this distance is x, and this is the resultant x. Now let us find this value. 12 sin 50 into 2, 12 into sin 50 into 2 minus 6 into 6, 36. It is giving minus 17.61, minus 17.61. As this net moment is negative, what does it mean? The resultant should produce the same moment, that is negative moment means anti-clockwise moment. For that we have to attach minus sign, and it is possible only when we place the resultant here, because after placing resultant here it will produce anti-clockwise moment, because if you fix this point and apply force here, it will try to rotate the object in anti-clockwise direction. If you place it here, it will produce clockwise moment, which is wrong, because we are getting net moment as negative. Means resultant should produce anti-clockwise moment. Therefore x is equal to minus 17.61 upon minus r, minus 17.61 upon value of r is 4.89 is equal to 17.61 upon 4.89, which is equal to 3.6 meters. 3.6 meters. This gives the location of resultant by using Varignon's theorem of moments. X is equal to 3.6 meters, and the angle of resultant is 40.69 degrees. That's all for this short video. In this video we have learned how to find the resultant of coplanar non-concurrent system and how to find its location by using Marignon theorem of movements. Thanks for watching. Goodbye.